What if I told you that somewhere in the mountains of Pakistan, 120-year-old men are still climbing steep terrains with the agility of someone half their age? That in a small Greek island, centenarians wake up every morning with crystal-clear minds, ready for another day of physical labor? These aren't fairy tales or exaggerations. They're documented realities that have puzzled scientists for decades. Welcome to the extraordinary world of human longevity superpowers, where ancient dietary wisdom might hold the key to stopping the aging process itself. In the remote valleys of Hunza, Pakistan, people don't just live to 100, they thrive beyond it. Mir Saida Ali, documented at 127 years old, was still working in his fields when researchers first encountered him in the 1970s. His daily routine? A breakfast of apricot kernels, a handful of walnuts, and fermented mare's milk. No processed foods, no industrial agriculture, just the same dietary patterns his ancestors had followed for over 1,000 years. But Hunza isn't alone in defying our understanding of human aging. On the Japanese island of Okinawa, researchers discovered something extraordinary. The local population had the highest concentration of centenarians on Earth. Even more remarkable, these elderly individuals showed virtually no signs of the chronic diseases that plague Western societies. No heart disease, minimal cancer rates, and cognitive function that remained sharp well into their hundreds. Dr. Bradley Wilcox, who spent decades studying Okinawan longevity, made a startling observation. Their biological age appeared to be 20 to 30 years younger than their chronological age. Blood tests, bone density scans, cardiovascular assessments. Every metric suggested these individuals had somehow slowed their internal aging clocks to a crawl. The pattern repeated itself across the globe. In Sardinia's mountainous regions, shepherds in their 90s continued herding sheep across challenging terrain. In Ikaria, Greece, men and women approaching their centennial years maintained active social lives, clear memories, and robust physical health. Scientists coined a term for these remarkable places: blue zones, geographical regions where exceptional longevity wasn't the exception, it was the rule. The first major breakthrough came when researchers began analyzing the dietary patterns common to all blue zones. Despite geographical separation and cultural differences, these communities shared striking nutritional similarities. The Hunza people consumed large quantities of apricots, including the kernels most cultures discard. Okinawans built their meals around purple sweet potatoes, bitter melons, and fermented soybeans. Sardinians thrived on wild herbs, goat cheese, and a specific variety of red wine. Icarians incorporated wild greens, honey, and herbal teas into their daily routine. What initially appeared to be random dietary choices began revealing sophisticated biochemical patterns. Laboratory analysis showed these foods contained unusually high concentrations of compounds that modern science was just beginning to understand. Polyphenol, flavonoids, and rare antioxidants that seemed to interact with cellular aging mechanisms in unprecedented ways. The real revelation came from caloric restriction studies. In the 1930s, researcher Clive McKay made an accidental discovery that would revolutionize longevity science. Laboratory rats fed 30 to 40% fewer calories than normal didn't just live longer. They lived dramatically longer, sometimes doubling their natural lifespan while maintaining youthful characteristics well into advanced age. For decades, this remained a laboratory curiosity until researchers realized something profound. Blue zone populations naturally practiced forms of caloric restriction without even knowing it. The Okinawan cultural practice of hara hachi-biyu, eating until 80% full, created a natural caloric deficit. Hunza's seasonal eating patterns included extended periods of minimal food availability. These weren't survival strategies, they were longevity protocols encoded in cultural wisdom. Modern molecular biology began revealing the mechanisms behind these observations. When cells experience mild nutritional stress, they activate ancient survival pathways that actually enhance their repair and maintenance systems. This process, called hormesis, triggers the production of specialized proteins that literally clean and rejuvenate cellular components. Dr. David Sinclair's groundbreaking research at Harvard identified specific genes, called sirtuins, that respond dramatically to caloric restriction and certain plant compounds. These longevity genes act like cellular repair crews, fixing DNA damage, eliminating defective proteins, and maintaining mitochondrial function. The remarkable discovery was that many foods consumed in blue zones naturally activate these same pathways. Resveratrol from Sardinian red wine, quercetin from Hunza apricots, curcumin from traditional spices. These weren't just nutrients, they were molecular switches that could theoretically extend human lifespan by decades. But the science revealed something even more extraordinary. Autophagy, the cellular process where cells literally consume their own damaged components, could be triggered through specific dietary patterns. Japanese researchers discovered that certain compounds in traditional Okinawan foods could induce autophagy, levels typically only seen during extended fasting periods. This meant that centenarians in blue zones weren't just avoiding disease. They were actively reversing cellular aging through their food choices. Their cells were performing constant internal housekeeping, removing accumulated damage that causes aging in typical populations. The implications staggered the scientific community. If dietary compounds could activate these pathways, could we essentially hack the aging process? Pharmaceutical companies began investing billions in developing synthetic versions of these natural compounds. Clinical trials with metformin, a diabetes medication that mimics caloric restriction effects, showed promising results in extending healthy lifespan in laboratory animals. Meanwhile, researchers studying extreme cases of longevity uncovered even more puzzling phenomena. Emma Morano, who lived to 117 years, consumed raw eggs and cookies daily, a diet that should have killed her decades earlier by conventional nutritional wisdom. Yet her blood work resembled that of a healthy 40-year-old. Genetic analysis revealed she carried rare mutations in genes associated with DNA repair and cellular maintenance. This raised a disturbing question. Were blue zone diets working because of what they included, or because of what they excluded? Modern processed foods contain thousands of chemical compounds never encountered in human evolutionary history. Perhaps longevity wasn't about consuming specific nutrients. Perhaps it was about avoiding modern dietary toxins. Recent studies on telomeres, the protective caps on chromosomes that shorten with age, provided another piece of the puzzle. Researchers found that people following traditional Mediterranean diets, similar to those in blue zones, had significantly longer telomeres than those consuming typical Western diets. Even more remarkably, some individuals showed evidence of telomere lengthening over time, suggesting actual biological age reversal. The rapamycin studies pushed these findings into science fiction territory. This compound, originally discovered in Easter Island soil, extends lifespan in every organism tested, from yeast to mammals. When researchers found that certain traditional foods contained rapamycin-like compounds, the possibility of natural life extension through diet became scientifically plausible. Dr. Walter Longo's fasting-mimicking diet research revealed that cycles of severe caloric restriction could literally regenerate immune systems in elderly individuals. Bone marrow would produce new, younger immune cells, effectively resetting the body's disease-fighting capabilities. Some participants showed biological age reversals of 10 to 15 years based on immune system markers. But perhaps the most extraordinary discovery came from studying cellular reprogramming. Scientists found that specific combinations of dietary compounds could influence epigenetic markers, essentially rewriting the instructions cells use to read genetic information. This meant that dietary choices could potentially override genetic predispositions toward aging and disease. The ethical implications of these discoveries are staggering. If human lifespan could be extended to 150 or even 200 years through dietary interventions, what would happen to society? Economic systems based on retirement ages, social structures built around generational change, resource allocation for an aging population, everything would need fundamental restructuring. Some researchers warn of creating a biological caste system where longevity becomes a privilege of the wealthy. Others argue that extending healthy human lifespan represents our species' greatest achievement. The debate intensifies as life extension technologies move from laboratory curiosities to potential clinical realities. Current research suggests we're approaching a tipping point. Combinations of traditional dietary wisdom with modern pharmaceutical interventions might soon make dramatic life extension accessible. Companies like Calico Labs and Unity Biotechnology are investing hundreds of millions in developing treatments that target aging itself rather than age-related diseases. Yet the most profound truth might be the simplest. Communities that have maintained traditional dietary patterns for centuries have already achieved what modern science is desperately trying to replicate in laboratories. Their superpower wasn't genetic luck or environmental factors. It was the accumulated wisdom of eating in harmony with biological systems evolved over millions of years. The Hunza elders climbing mountains at 120, the Okinawan Centenarians maintaining sharp minds, the Sardinian shepherds working well past 100. They represent proof that human aging might be far more malleable than we ever imagined. Their ancient diets might indeed hold the keys to stopping aging, not through exotic supplements or expensive treatments, but through rediscovering nutritional practices our ancestors knew intuitively. As we stand at the threshold of potentially revolutionary longevity breakthroughs, perhaps the most remarkable discovery is that the future of human aging might be hidden in our past. The question isn't whether we can stop aging. It's whether we're wise enough to learn from those who already have.